Hello and welcome to yet another segment of our programming language where we seek to analyze and to understand how we can be able to analyze data using the R software and also to be able to get the outcome necessary for drawing conclusions and inferences about a particular population distribution. So I'm going to briefly go through a recap of what we did yesterday. And again, much acknowledgement to Denaco Enterprises for the resources and also for enabling this platform to work so that we can be able to share knowledge on how to use the software to perform business, industrial, or even educational analysis of statistics. So proceed to launch. Again, as I told you, click on Start R Studio. You will see that this window will be displayed over here. And just a brief overview. You can see this is what we've been doing, and when you look at the history, it gives you all the specific commands that we were able to enter into the system and instruct R to be able to execute them, to run them. So I will just clear the console. Similarly, I'm going to clear the sources so that it allows me to get all the way from the beginning for the purpose of understanding and knowing where the derivation came from. So I'm going to proceed to clear this one as well. Let me just highlight all of it and make a deletion. Great. Okay, Control A and then delete. Okay, so as I said yesterday, you could introduce data from using a number of ways, and one of them, as we discovered, was that you could import from an external source, which included just proceeding to clear all these tabs so that we can just begin speedily. Okay, now supposing you want to know the kind of datasets that R offers for your use, how do you do that? We said you use the command data. So you type in data, open the brackets, close the bracket, and you leave it like that. You highlight the command as you always said, and then you instruct R to run it. And you can see a list displays over there telling you exactly the kind of datasets that are available for practice on R. And you can see from here we have BJ sales, bjsales.lead, air passengers, CO2, BOD, judge ratings, and so on. So okay, so we can we can just pick one from it. Say data on trees. If you want to display, if you want to use data on trees, and you want to display it on the environment window, then it's easy. You type in data. Okay. Sorry, on the source window, because that's where we enter the commands. You type in data, open the brackets, okay, open the brackets, and then select the kind of data set you need. So trees, close the brackets, but it's also important to ensure that you put them in quotes, because that's how you tell R that that is a data set you want to use. So make sure you put it in quotes, after which you highlight and then you run it. You will see that the dataset appears on the environment panel. If you wish to use, let's say, air passengers, then you key in data, open the brackets, okay, passengers, and you can see it's here. Click on it, air passenger, and you see they are in quotes. If you don't put quotes, you'll get an error code. So the moment you do that, highlight it and then you run it. Okay, you can see it also displays it. It means it's a dataset option you can be able to use. If you wish to display it, I had someone ask yesterday, if you wish to display some of this data, you just click on it. You can see there's a display of how it appears over time, forces, passengers, blah blah blah, and so on. April, March, June. Okay, when you look at the trees data, you can be able to tell the girth, the height, and the volume according to the distribution given therein. So we will just proceed to do an analysis. Now, supposing you're looking for the structure, you want to know the number of rows and columns. So let's begin with the rows. The number of rows that exist in a data set. You use the nrow command. Okay, nrow command, which is this, allows you to be able to, of course, you insert the name of the data set. For example, you're looking for nrow for trees. Trees. You select trees. Okay, highlight it, run it. You can see that the output here is that there are 31 rows on the trees dataset. Secondly, supposing you want to find the number of rows on the air passengers dataset, then you say nrow, open the brackets, air passengers. Okay, air passengers. Then make sure that you highlight it and then click run. It says null, means it's a varied range, including that it could be organized in a uniquely crafted manner, like you can see here. You see there's this 1949 to 1960 data. There's also a place where it recurs and so on and so on. So that's why it's returning null, unlike this one, which is straightforward. You can see that it just ranges from 1 all the way to 31. Okay, supposing you want to check on rows, columns, you use the dimensions command. It tells you, it gives you a brief overview of how the data appears, and this is how you do it. You come to the source, click dimension or dim command, dim command, then the name of the dataset, say trees, close the bracket, highlight it. Okay, then run it. You will see that there are 31 rows and 3 columns, and true to this, you can see that there are 31 rows over here, and the columns, the number of columns are 1, 2, 3, meaning the number of variables are 3. Next, you can check the structure, which tells you the kind of variables that we have, whether they are string or numerical. And how to do that is that you key in the structure command, open brackets, name of the dataset, say trees. Okay, highlight it, run it. Okay, sorry, I think I misspelled. I told you yesterday, the moment you key in and you misspell the name of the dataset, you get an error code. So make sure this spelling here, you get it right so that it matches the dataset, and the moment you highlight and run it, you observe that you will get an output, and there are 31 observations of 3 variables. The variables are girth, height, and volume, and you can see for the girth, they're telling you it's numerical, yes, 8.3, 8.6, in that order. It's continuous, numerical for height, numerical for volume. Good. Next, we can check an overview of the first 6 or the last 6 by using the head and the tail command. In this instance, you can say head. Okay, click on the command and you give the series name, which is trees. Make sure again the spelling is right, otherwise you get an error code. Then you run the command, and you can see that the structure of the first six appears as follows. If you wish to see the structure of the last six, which I told you is just the general overview of what to anticipate, then you will say tail, open the brackets, the name of the variable, okay, tree, the name of the data set, trees, highlight it, run the command, and you can see the last six observations look the way you see on your console. Next, which is very important now, is the measures of central tendencies. Also together with the measures of dispersion, we're going to look at them. That is, measures of central tendencies are the mean, median, mode isn't enabled on R, but we can look at the mean and the median, and then we will proceed to check out the measures of dispersion, which is the standard deviation, the variance, the maximum, minimum, and the range, together with the quartiles and the percentiles where possible. So first thing we need to know is that you use the mean command to be able to get the averages, mean, open the brackets, and this is unique in the sense that to be able to get an output on mean on the console, you have to key in the name of the data set, which is trees. I don't know why it's so it is trees, okay. Then you separate it from the variable you wish to find the descriptive of by using a $ shift 4. Then you select the variable. Say you're looking for the average or the mean girth of the girth, so you select girth. In that sense, you can see we have the command or the function mean, and then this is the data set name separated by a $ from the variable you're looking for. You highlight it and then you run it. Okay, you can see that the mean girth for the trees is 13.24839. okay, let's proceed. We go to mode, not mode but median. So if you're looking for median, then you will say median, the name of the dataset is trees, separate it using a $ shift 4, and we're looking for the median girth, and that tells us that the median girth, you run the command, you can see that the median girth is 12.9 units. Now supposing we're looking for variance, we will use the var command, say variance. Okay, before I go to the variance of the measures of dispersion, I want you to understand something. Supposing you want to avoid the cumbersome procedure of having to insert a $ to separate the name of the variable and the name of the data set in order to secure a mean or a median, you can use a simple command that is provided by R, which is called attach. The attach function enables you to pin the name of the dataset such that you don't have to keep repeating it when you need to find some of these statistics. So you say attach the name of the dataset, trees. Okay, the moment you attach it, let us run it. The moment you run it, it means that the dataset in question has been pinned or attached, such that when you want to find the measures of or any other descriptives, it will be referred to automatically. For example, if you want to calculate the mean now, you just type the mean command, brackets, name of the variable you wish to find the mean of or the average of, and this is the girth, and you can see it appears there. So you highlight it and proceed to run it, and you can see that the mean girth is 13.24 and so on. If you wish to find the median, you can see that the median is so you calculate the median girth, okay, and remember girth is spelled with a capital G according to the dataset that we have. So you make sure the spelling is right, the casing is right. Without that, you will get an error code. So you proceed to run it, and you can see that the median is 12.9. Okay, just the same way we found over here. Now, if you wish to disassociate the proceeding descriptives from the file, from the dataset you just attached, you use the detach formula, to to dissolve the effect of the file you already pinned. If you want to unpin it, you use the detach command, which is detach detach okay, you use the detach command. Just wondering why it wasn't displaying. It's because of that. So detach, meaning the name of the dataset, follows suit and you can highlight and proceed to run it, and you can see it has been detached. So anytime you try to look for the mean, for example, you're looking for an average of the girth of the tree. Okay, girth of the tree, and you're looking for the average. So when you proceed to run it, you get an error code, meaning there is no data set to refer to. So the R software has not been instructed on what data set exactly to find the mean of. That's why it's giving you that. So to be able to do that, to be able to remove the error code, then you have to type the command mean, open the bracket, the name of the data set, because it wasn't pinned in the first place. So you have to say trees. You have to separate it with a $sign from the variable you wish to find the mean of, which is the girth, and you select it, you click run, and you can see now we proceed to get 13.24 the same way we did. Okay, okay, so now that we know the attach function, we can proceed to just be using it. Attach attach. Okay, you can proceed to use it. You key in the name of the formula, trees. Okay, and you run it. Good. Now from this point, let's find the variance, measures of dispersion, which is the spread. How spread is the data between outliers and so on. So you say how spread is the data set between the maximum and the minimum. That's why it shows you how they are distributed or how they are dispersed over different time periods or different observations. So if you're looking for the variance, therefore variance is the variance command, and you say the variance of something like the tree. Say you're looking for the girth, so you can say trees formula. I think this one will give you, looking for the variance of the data set, and you can see that you have been given a variance covariance matrix, meaning that this is the variance 9.8. Variance of the girth is 9.84. If you're familiar with the variance covariance matrix, then it means we select this. 40.60 is the variance of the height. Okay, 270 is the variance of the volume. This is the covariance between girth and height. This is the covariance between girth and volume. This is the covariance between height and you see they're different, they're similar, some of them are the same. So the covariance essentially implies the correlation. How does girth relate to height? How does girth relate to volume? How does height relate to girth? And so on and so forth. Next, we can be able to find the standard deviation using the SD function, and you can say trees. Okay, highlight it, proceed to run it. Okay, that's an error because we need to this one doesn't have a matrix, so we need to be very specific about the kind of variable that we need to find the standard deviation of. If it's height, then make sure you key in the height, and you can see it is appearing here. Make sure the format looks the same. Run it, and you can see we have the standard deviation of the height. To confirm this, you can find the square root of height over here, the variance for height, which is 40, and you will get roughly 6.37, and that is true, it's factual. Supposing we are finding the standard deviation of girth. Okay, all right, so you're finding the standard deviation of girth. We proceed to run it. Then you can find 3.13. So you can see that the standard deviation of girth is 3.1, and you can see from this variance covariance matrix that the variance for girth was 9.84. When you find the square root of 9.84, it is equal to 3.138139, which means we are correct. Next, we are going to proceed to find the minimum, maximum, and then using the 5num analogy. So then finally we will do the summary and we'll see how that works. So if you want to calculate the minimum, then you use the min command and insert the variable, say the minimum of girth of trees. Make sure the format is right, highlight it, proceed to run it, and you can see that the minimum girth for a tree is 8.3. okay, it means that the least possible girth that a tree could achieve was 8.3. If you're looking for the maximum, on the other hand, you use the max command. Then you proceed to type in girth, and you can see that the maximum girth possibly attained is 20.6. The thickest tree, let's say in a sample frame, is 20.6 units, as you can see from this one. If you wish to find the range, then you find the difference between this and this, and you can see 20.6 minus 8.3 essentially just gives you the range, which is the dispersion, the difference between the maximum and the minimum. That is the purpose of finding minimum and maximum. Also, there's this if you wish to find a rough estimation or a summary, a rough estimation of the minimum, the lower quartile, the median, the upper quartile, and the maximum, then you use the 5num command. Okay, okay, I'm typing it on the, I didn't want to type it there, I wanted to type it on the source window because that's where we make the instruction. So you say 5num, okay, and you say 5num of let's say girth, because we want to see the variable girth. 5num command, okay, highlight it, then proceed to run it, and you can see that we have been given 8.30. Let's see if they actually do much. So we say the minimum amount here is 8.3, and you can see we have 8.30 here. The maximum is 20.6, and you can see we have 20.6 over here. And standard deviation of, okay, this is the first quartile. You will be able to see this in summary, and this is a median, and you can see in the median over here we had 12.9 for girth, and upper quartile is 15.25, which you will be able to see in the summary. Now, instead of going through this entire process of finding a statistic or parameter one after the other, you can just proceed to do the summary statistics or the descriptive statistics of the entire data set by using the summary command. And how do you do that? You type summary, open the bracket, okay, proceed to type the name of the dataset, trees. Okay, when this is done, highlight it and run it, and you can see now we have a minimum for all variables. So you have minimum girth, we have first quartile of the girth, which is 11.5 as we have seen in the 5num. We have the median, which is 13.25. We have the third quartile, which is, we have the maximum, which is here, and so on and so forth. And that is quite a good way of making an analysis. And it's also fast and reliable. You can even create a table from it by highlighting and proceeding to use other tools like Excel to be able to help you to generate tables from it and then make your presentation. Now, supposing we do not want to use the dataset already provided for us and by R, that we used to do, we wish to do a professional analysis, or supposing we're engaged in a project and we want to do it, and we have our own data set, let's say in Excel, we wish to bring it in for analysis. How do we go about it? One, you proceed to the procedure I told you. You go to files, then you go to import dataset. From where? From Excel. Okay, depending on where on your computer you have stored your data, you browse like I told you. Mine is on desktop. I proceed to look for it. It's called insurance. I select it and then I click open, because the viewer is open, so you can be able to review it over here. And then after the process is complete, you can proceed to import. Okay, the process is complete now. I can proceed to import my dataset, and you can see the importation is complete. We have an insurance dataset that has been added to the environment, and also you can see it on display over here on the source. Now let's go back to the coding area. The source. Now, supposing you wish to use the files from the insurance, then how do you make sure that R recognizes that the new dataset you wish to be analyzing is that insurance dataset? You have to attach it, just like we said, attach. So you type in the attach formula. After attaching it, then you insert the name of the dataset, insurance, and make sure the spelling is accurate, the casing is accurate, and you can see there. So the moment you have attached it, run it. It means henceforth the data that we will be analyzing is that of insurance. And so we can calculate the summary statistics for insurance. And as you can see, insurance, make sure the spelling and the casing is right. We're looking for the summary statistics of insurance. So you execute by clicking run, and you can see that we have a summary of everything that we need over there. Otherwise, I want to thank you so much for this session. I had said something briefly about packages, and I remember I told you about the psych, I told you about the read Excel. I just made a brief introduction to enable you to understand what I'm talking about, and in the coming classes I will be sure to tell you about some of the most interesting packages that are available for use, and just give you an interesting format in R on how you can present your materials. And also we will proceed to make analysis, or we will proceed to test hypothesis, we will proceed to check causality using various tests. We'll be able to test normality, we will be able to do a regression analysis, and so on and so forth. And from this we will also try to find out if there's a different way in which data can be presented, if there's an easy way in which you can order Excel to perform or execute a specific command in a way that you prefer it. And once we be able to do that, I think we will have increased our proficiency in matters R, and I believe that the learning activity will progress unhinged. As I say thank you, I'd like to advise that you review intensely some of the findings that we have been able to accomplish over here. Look at the behavior of the source window, the behavior of the console in response to the source window commands. Also, take a look at how the environment and the history and the environment panel are behaving and how they are keeping records. Together with the packages, okay, know how to move around. Supposing you want to install a package, you must know that on this particular panel, you must be able to select on the packages tab before you can see the install button, and so on and so forth. So look forward to seeing you in the next session, and I look forward to engaging with you. I look forward to answering questions, and I look forward to learning more. Otherwise, thank you so much.